So let's apply a rotation to a parabola. So let's rotate the parabola. Y squared is equal to 4ax by pi over 2 radians counterclockwise. Let's first recall what we know about this parabola. This parabola has a focus at the point A0. The vertex occurs at the origin, and the directrix occurs at the line x is equal to negative a. Now, if a is positive, this parabola opens to the right, and if a is negative, this parabola opens to the left. So a rotation of a point pi over 2 radians counterclockwise is the transformation, the active transformation, that takes the point xy to the point negative yx, and the passive transformation corresponding to this active transformation is the transformation that takes the point xy to the point y minus x. So to apply a transformation to an equation, we're going to apply the passive transformation. So anywhere we see x, we're going to replace it with y. And anywhere we see y, we'll replace it with negative x. And so our rotated parabola is the parabola negative x quantity squared is equal to 4 times a times y, or x squared is equal to 4ay. So what happens to the focus? For a focus, which is a point, we're going to apply the active transformation. And so the point A0 is transformed to the point 0a. The vertex remains at the origin, and the directrix is a line that isn't an equation, and so we will use the passive transformation. So anywhere we see x, we replace it with y, and so the directrix occurs at the line y equals negative a. Now, if a is positive, then this rotated parabola opens upward, and if a is negative, the rotated parabola opens downward. Okay, so let's check our work. We'll plot the parabola x squared is equal to 4 times a times y. Notice that this parabola is rotated 90 degrees counterclockwise, or pi over 2 radians counterclockwise, compared to the parabola y squared equals 4ax. And let's plot the focus, which we determined should be the point 0a. The vertex remains at the origin, and the directrix is the line y equals negative a. So for positive values, the parabola opens upwards, and for negative values of a, the parabola opens downwards. So next, let's apply a rotation to an ellipse. So let's rotate the ellipse x squared over a squared plus y squared over b squared is equal to 1 by pi over 2 radians counterclockwise. So again, first let's consider what we know about the ellipse. X squared over a squared plus y squared over b squared is equal to 1, where b squared is equal to a squared times the quantity 1 minus the eccentricity squared, and a is greater than or equal to b, which is positive. This ellipse has a center at the origin. The ellipse has two foci. One occurs at the point negative a times the eccentricity 0, and the other occurs at a times the eccentricity 0. This ellipse has two vertices, and those occur at the points negative a0 and a0. The ellipse has two co-vertices, which occur at the points 0, negative b, and 0b. And the ellipse has two directrices, one at the line x is equal to negative a divided by the eccentricity, and the other is the line x is equal to a divided by the eccentricity. So again, to apply a transformation to an equation, we're going to use the passive transformation. So anywhere we see x, we're going to replace it with y, and anywhere we see y, we're going to replace it with x. And so our rotated ellipse is y squared over a squared plus the quantity negative x squared over b squared is equal to 1, or y squared over a squared plus x squared over b squared is equal to 1, where, once again, we have that b squared is a squared times the quantity 1 minus the eccentricity squared, and a is greater than or equal to b, which is positive. So let's consider what happens to the different points. The center remains unchanged. It remains at the origin. The foci are points. So we're going to apply the active transformation. So the y values in both cases are 0, so those are unchanged, and the x values will not be changed. So the foci are the points 0, negative a times e, and 0 times a times e. The vertices occur at the points 0, negative a, and 0a. The co-vertices occur at the points negative b0 and b0. And finally, the directrices we determine by applying the passive transformation. And so we have the y is equal to negative a over e, and y is equal to a over e. Okay, so let's check our work. We use the variable k for eccentricity, and we'll set the eccentricity to 0.6. So now we can define our parameter b in terms of the parameter a. It is a times the square root of 1 minus the eccentricity squared. And so now we can plot our ellipse, y squared divided by a squared plus x squared divided by b squared is equal to 1. So now let's check our points. Our center, we calculated to be the origin. We calculated two foci. One foci At the point 0, negative a times the eccentricity. Another foci at the point 0 times a times the eccentricity. Two vertices, one at the point 0, negative a, and one at the point 0, 0a. We have two covertices, one at the point negative b, 0, and one at the point b, 0. And we have two directrices, one at the line y is equal to negative a divided by the eccentricity, and one at the line y is equal to a divided by the eccentricity. So notice that as compared to the ellipse x squared over a squared plus y squared over b squared is equal to 1, this ellipse is rotated by pi over 2 radians counterclockwise. So next, let's rotate the hyperbola. X squared over a squared minus y squared over b squared equals 1 by pi divided by 2 radians counterclockwise. So again, first we consider what we know about the hyperbola. X squared over a squared minus y squared over b squared is equal to 1, where b squared is equal to a squared times the quantity the eccentricity squared minus 1. The hyperbola has a center at the origin. The hyperbola has two foci at the point negative a times the eccentricity 0 and a times the eccentricity 0. Two vertices at the points negative a 0 and a 0. Two covertices at the points 0, negative b and 0b, and two directrices at the line x equals negative a divided by the eccentricity, and x is equal to a divided by the eccentricity. So again, for our transformations, the rotation by 90 degrees or pi over 2 radians counterclockwise is the transformation that takes the point xy to the point negative y x, and the corresponding passive transformation for that active transformation is the transformation that takes the point xy to the point y minus x. So to rotate, to apply this rotation to the equation, we apply the passive transformation. So anywhere we see x, we replace it with y, and anywhere we see y, we replace it with negative x. And so we have y squared over a squared minus the quantity negative x squared over b squared is equal to 1, or y squared over a squared minus x squared over b squared is equal to 1, where b squared is a squared times the quantity, the eccentricity squared minus 1. So let's consider what happens to the points. The center is unchanged and remains at the origin. So let's look at the foci. So we apply the active transformation. The y values are 0, so they will not be affected. And so the foci are 0, negative a times the eccentricity, and 0, a times the eccentricity. The vertices occur at the points 0, a, 0, negative a, and 0, a. And the covertices occur at the points negative b, 0, and b, 0. And the directrices are given by equations, and so we apply the passive transformation. Anywhere we see x, we replace it with y, so the directrices are the lines y is equal to negative a divided by e, and y is equal to a divided by e. So again, let's check our work. We'll set the eccentricity to 1.2, and then we can define our parameter b. In terms of the parameter a times the square root of the eccentricity squared minus 1. And now we can plot our hyperbola, y squared divided by a squared minus x squared divided by b squared is equal to 1. So notice that compared to the hyperbola x squared over a squared minus y squared over b squared equals 1, this hyperbola is rotated by pi divided by 2 radians counterclockwise. So let's check our points. Our center occurs at the origin. We have 2 foci. One occurs at the point 0, negative a times the eccentricity. The other occurs at the point 0, a times the eccentricity. We have 2 vertices. One occurs at the point 0, negative a. Another occurs at the point 0, a. We have 2 covertices. One occurs at the point negative b, 0. And the other occurs at the point b, 0. And we have 2 directrices. One occurs at the line y is equal to negative a divided by the eccentricity, and the other occurs at the line y is equal to a divided by the eccentricity.